These are notes over Chapter 2, Section 2. Right. We have two different ways that we can take measurements. They can be quantitative or qualitative. So quantity is a quantitative result. So we have to have some kind of numerical value. They have to have units. So every time you give me a number, there has to be some kind of letters after it telling me what that number represents. How long we carry out our number depends on how we measured it or what kind of mathematical function we used, and we'll talk about that in a later section. When we take measurements, we have the SI system, and then we have the metric system. The SI system is what is understood worldwide. So some of those units may not be very practical for us in lab, but if we were doing some kind of work or some kind of correspondence with someone from another country, they may not be familiar with some of the metric units. So then we would have to use SI units. Okay, for length, they have listed all of the common ones. So meter is the international SI unit. Meters aren't practical for us in chemistry. They're practical in physics when we're measuring long distances, but most of the time in chemistry, we're going to use centimeters, maybe even millimeters. For volume, the SI unit is a cubic meter. That's huge. Remember, a meter is just over 3 foot, so 3 cubic feet. That's massive. That's how we would measure the volume of a swimming pool. In our lab, we will use milliliters. The SI units for mass are the kilograms. That's definitely too large for us as well. A kilogram of sugar would be about the size of a brick. So one of the red bricks they use to build houses or from the outside of the school, that's about 1,000 grams of sugar. We just use regular grams. A packet of sugar that you get from a restaurant is about 1 gram of sugar. And for temperature, the SI units are Kelvin, but in lab, we use Celsius. It's just much more practical for us in Celsius. Here they go through a couple more. We won't have to worry about those. All right, so mass is the measure of the quantity of matter. This is something we've talked about already. But there is a difference between mass and weight. Weight is how hard gravity is pulling on you. Mass is how much matter you contain. So if we go to the moon, your mass doesn't change. You didn't change size or shape. But what did change is your weight, because that's gravity dependent. All right, so SI unit for length is a meter. If we're talking about driving distances, like the distance from here to Jonesboro, Arkansas, we would measure in kilometers. But in lab, centimeters is much more practical. These are SI units for different substances and formulas. SI unit is the cubic meter for volume, but again, we just use milliliters. This is really good to know right here, that 1 milliliter is equal to 1 cubic centimeter. Cubic centimeter is 1 cc. This is something we talked about a little bit in the last chapter. The formula for density is mass over volume. If you had Miss Smith, she drew the density triangle. Let me get a triangle real quick. And then she kind of cut the triangle up. So density is equal to mass over volume. And remember, in between density and volume, we should have a multiplication symbol here. So you just cover up whatever letter you're trying to solve for. So if we're looking for density, cover up the D, it's mass over volume. If we're solving for mass, cover up the M, and it's density times volume. And if we're solving for volume, cover up the V, and it's mass over density. We will usually use grams per milliliter for density. So these are some common densities. This one for copper, you'll need it in a lab later next week, 8.92. It's in your book too, so you'll be able to find it. If you will look, the density of ice is 0.92 grams per cubic centimeter, and water is 0.998. So ice and water, those are the only substance where the solid form floats in the liquid form. So the solid is less dense than the liquid. Right, this is a sample problem. I'm not going to work them out with you, but if you want to work them out, you're more than welcome to. I'll leave a slide. You can pause the video, work it out, and then the next slide will have the answer. All right, conversion factors. We use conversion factors to help us change from one set of units to another. We're going to first start out with very common conversion factors, and then we'll move to ones that are more scientifically used. So the first conversion factor example they give us is a ratio between dollars and quarters. So we can say there are 4 quarters in a dollar, or we can say $1 has 4 quarters. Either way, they both represent the same thing. So we can use these conversion factors to help us solve problems. So if we want to know how many quarters are there in $12, we start with $12. We use the ratio of 4 quarters to $1 on top. And the reason why, we start out with units of dollars, but we want to end with quarters. So in math, when we want to cancel something out, we divide them. We put one on top and one on bottom. So since we have dollars here on top, we have to put $1 on bottom so that the dollar cancels out, and we're left with quarters. So now if we multiply 12 times 4 divided by 1, that tells us there are 48 quarters. You could have done that in your head. You didn't have to write all this out. But once we start using scientific units, this will get a little more confusing. If you write it out step by step for the easy ones, when you get to the hard ones, it'll come much easier for you. All right, so here's one where they're using the metric scale. I don't teach the metric scale using conversion factors. I just teach you to memorize the order of the metric scale and then figure out which way to move your decimal point. So I'm going to kind of skip over these problems. If you want to use conversion factors to go up and down the metric scale, you're more than welcome to. You'll just follow the directions that are given to you in the book. If you want to do the metric scale by just moving your decimal, I'm going to post a separate video to show how to do that. All right, I'm going to stop this video here before I go on to section 3.